Chalo, let us move on to circles. We start with the basic definitions first. Means basic definition in the sense we first start with the basic geometry of circles, and then we see the coordinate point of view. We first see from the geometry point of view. A lot of questions can be solved from geometry itself. We'll solve certain geometry problems today also. A lot of questions can be solved using basic geometry, which you all study in 9th of 10. Have you all studied circles in 9th or 10th? Most likely you have studied CBSE as well as for ICSE. You'll have studied, right? A basics of circle geometry, not the coordinate part. I'm asking you for the circle geometry. A bit of circle though you have studied in 9th of 10. The basic things. Acha, chalo. Let us move on to circles. We start with the basic geometry of circles. We start with the basic geometry with circles. We start from the theorems. Chalo, first theorem, one by one. Very quickly take this down. Equal chords subtends equal angles at the center. Equal chord subtends equal angles at the centers. This is actually what a brief recall of your 9th and 10th, whatever theorems you have studied in 9th of 10th. So we are going to recall over here. Equal chord subtends equal angle at the center. Equal chord mane, first of all, you take two chords which are in equal in size. You take two chords which are equal in size. One chord is in this, okay, and second chord is this. You take two chords, does not look like equal chords. Take two chords which are equal in size. This one and this one. Okay. Two chords which are equal in size. This says that the chord subtends equal angle. Equal chord will subtend equal angle at the center. Which means if you just create the triangle over here by joining, take the center over here, you take the triangle here. Okay. This way. Once again, it does not. It's a freehand diagram, so please. This angle. It is saying that this angle and this angle are equal. Equal chord will subtend equal angle at the center. Okay. The angle subtended at the center is the same. Very simple thing. What you can do, very simple to prove also. Okay. Just a brief idea to prove this thing. You don't need the proof. You don't need the proof of all of them because the proof is somewhat you have done in 9th or 10. Now you need the application of the theorems. So you have to keep in your mind. But still, I'll give you the idea for the proof of some of the theorems. What you can do is you can drop the perpendicular from here. Okay. You just take a perpendicular from here. Okay. I'm dropping a perpendicular. And this is what? The radius. This is the radius and this is also the radius. You do the same thing for here also. I'm dropping the perpendicular. I am dropping the perpendicular from here. Okay. This is the radius. This is also the radius. So it's kind of an isosceles triangle which we are having over here, right? And you know that in isosceles triangle, whatever is the perpendicular bisector and the median, all of these are what? Means the perpendicular, median, and the angle bisector, all of these are equal in isosceles triangle. Right? So this will also act as the median. So this will fall at the midpoint, means this will get divided in the ratio 1:1. Getting my point? This will get divided in the ratio 1:1. So these two will be also equal. Similarly, these two also. Similarly, these two are also equal. Got the logic? So can you see that these two triangles are two congruent triangles? Look at these two triangles. Focus on these two triangles. This triangle, and this triangle. Can you all see that these two triangles are two congruent triangles? Hi, Anna. So if the two triangles are congruent, so this is the median actually. Yes, this is the median, and these two triangles are two congruent triangles. Okay. Two congruent triangles and the heights are also the same. This height is also the same. One equal chord will also subtend the equal height. This will also subtend the equal height. The heights are also the same. Getting my point? The heights are also the same. This height. I'm talking about this height. The heights are also the same. So your equal chord will subtend equal angle also. Equal heights also. Okay. So if these two triangles are congruent triangles, so definitely this angle, I'm talking about this angle, and this angle are definitely equal. This angle and this angle will be definitely equal. Getting my point, what I'm trying to say? So as this angle, similarly, in a similar way, these two triangles will be congruent and this angle will be also equal. Got it, got it. Yes or no? Got the proof? But you need the theorem only, not the proof. Just a brief idea of the theorem I have shown. Aa jao, chalo, next. Okay, what is the next one saying? Equal chords of a circle are equidistant from the center and vice versa. The same thing which I just now proved. It is now saying that the equal chords of a circle are equidistant from the center. That height I have shown. The equal chords of a circle are equidistant from the center. This height and this height will be the same. This height and this height, the heights which I have said, this red height, you all can see from here, from the diagram, this red height and this red height are the same. That's what they are saying. Equal chords of a circle are equidistant from the center. Chalo, next one. Quickly. Done. Chalo, next. Angle subtended by the arc at the center. Very famous theorem. Angle subtended by the arc at the center is double the angle subtended at any point. Angle subtended by the arc at the center is double the angle subtended by at any point on the remaining part of the circle. Okay. So what you do? You first take a chord. Let me make you understand what is this theorem. Theorem number 3. This is number 3, I guess. Number 3, the previous one was number 2. This was number 1, the first theorem. Then we have second theorem, then third theorem. Again, I am saying this is the summary of whatever we have studied in 9th or 10th standard. Okay. This will help you to do certain geometry based questions also. Every time you will see that every time you are not supposed to use any kind of coordinate geometry. Certain times you might also need to have, you might have to use this, this kind of basic geometry which you have studied in 9th or 10th. So angle subtended by the arc at the center is double the angle subtended at any point. So what I do first, I just take a chord over here. Okay. I simply take a chord over here and I join it with the center. Let's say, for instance, I join it with the center. Okay. And I, with the same chord is also, I'm joining one more triangle. I'm creating one more triangle over here. Take it. Acha. So if this angle is theta, then it is saying that this angle is 2 theta. That's the meaning of this thing. Angle subtended by the arc. This arc is subtending an angle of theta. Okay. This arc is also subtending an angle of 2 theta over here at the center. If this is subtending an angle of theta, then this will subtend an angle of 2 theta. That's it. Okay. Angle subtended by the arc at the center is double the angle subtended at any point on the remaining part of the circle. Okay. Done. You can prove this thing very simply, that this is a very basic proof. This is having a very basic proof. You can see, just briefly, I'll say, if you join this thing, okay, join this vertex and this center, fine, it's the radius basically. Okay, this complete total angle is theta. You take this to be alpha and take this to be beta. Let's say I'm dividing theta in terms of alpha and beta. Okay. And this is the radius, so as this is also the radius, because this is the center. From the center, you take any line passing through the center. Okay. From the center, you are taken to the circumference of the circle. That is the radius of the circle. So this is also R, and so as this red line which I have joined, this is also R. The thing is over here, if this is alpha, so as this is also alpha, right? If this is alpha, so as this is also alpha, because if this is R and if this is alpha, and here we have R, so as this is also alpha. You know, the front side of alpha angle is R, is given by R, so that is the side length actually. You know, so here we have R and here also we have R. So both of these angles will be alpha. So if this is alpha, so I can say that this much angle, how much is this much angle? How much is this much angle? 180 minus total angle, so total is 360. That is total. Acha, okay, fine. Yes. So 180 minus the remaining part is what? 180 minus, it's a triangle. So remaining part is what? 180 minus 2 alpha. 180 minus 2 alpha. How much is similarly? How much is this much part? Similarly, This much part is what? 180 minus 3 alpha. Sorry, 2 beta. And the total part is what? 360. Total part is what? 360. So this much angle is how much? 360 minus 180 minus alpha plus 180 minus beta. Yes or no? So 180 plus 180 will give you this thing only. 180 plus 180 will give you 360. So 360 and 360 will cancel out. It's 180 minus 2 alpha. Sorry, 180 minus 2 alpha and 180 minus 2 beta. So 180 and 180 will give you 360. 360, 360 cancels out. You're left out with what? 2 times of alpha plus 2 times of beta, which is 2 times of alpha plus beta, which is nothing but 2 times of theta. That's all. We are done. Because alpha plus beta was theta only. Got the proof? Yes or no? Okay. Next. Very simple thing. We are just playing with the angles, nothing else. So it's just basic playing with the angles. Angle in the same segment are equal. Next property. Angle in the same segment are equal. Okay. Next property is angle in the same segment are equal. There are two types of segment. You consider angle in any segment. Angle in a segment are always equal. What is a segment first of all? What is a segment? Segment is the area enclosed by the arc and the chord. When a segment means this is the segment. There are two types of segment. First of all, you take the chord because in this scenario we have a chord. So you take the chord over here. Okay. There are two types of segment. One is this segment. This part is known as the major segment, and this part is known as the minor segment. Major segment and minor segment. Major means the bigger one. Minor means the smaller one. Segment means, what is the meaning of segment? Segment means area enclosed by arc of a circle, arc and a chord. Area enclosed by arc and a chord. This is called a segment. Okay. So now coming back to the property says angle in the same segment are equal. Angle in the same segment are equal. So you take angle in any of the segment. Let's say, for instance, I take one angle over here. Okay. This theta. If this is theta, so you take one more diagram of this type. So here also this will be also theta. Angle in the same segment are equal. Okay. If this is theta, so as this is also theta. Any segment, anything, any segment, you take one angle over here also. This will be also theta. This will be also theta. Okay. And this is actually a direct application. You can say it's a direct application of the previous property itself. We can derive this thing with the help of this property only. Ki angle subtended by the arc at the center is double the angle subtended at any point on the remaining part of the circle. Okay, so this property can be derived from the previous property itself. And this is, I think, property number 4. This is number 4. Okay. So just remember, angle in the same segment are always equal. Same thing happens over here below in the minor segment also. If you take any two angles, those two angles will be always equal. Okay, fine. Draw the diagram. Chalo. Next, point number 5. Point number 5. Angle in a semicircle is 90 degrees. All of you know this thing. Angle in a semicircle is 90 degrees. All of you know this thing. All of you remember also. Angle in a semicircle. Semicircle means you take the diameter over here. Angle in a semicircle is always 90 degree. Angle in a semicircle is always 90 degree. Well-known property. Won't prove this. Let's not waste time doing simple proofs. Angle in a semicircle is always 90 degrees. Okay. Next one. Property number 5, then property number 6. This is also known to you. Sum of the opposite angles of a cyclic quadrilateral is 180 degrees. Okay. Sum of the opposite angles of a cyclic quadrilateral is 180 degrees and vice versa. So you take any cyclic quadrilaterals here. Okay. It's a cyclic quadrilateral. So here, sum of the opposite angles of a cyclic quadrilateral is 180 degrees. This plus this. ABCD. Angle A plus angle B, angle C is 180 degrees. So as angle B plus angle D is also 180 degrees. Sum of the opposite angles of a cyclic quadrilateral is 180 degrees and vice versa. Means if the sum of the any two angles is given to be 180, so definitely we can say that, and if 4 points are known to us, so definitely we can say that the quadrilateral which will be figured out will be a cyclic quadrilateral. Okay, if sum of any two angles is given to be 180, vice versa, means sum of any two angles is given to be 180, so we can definitely derive a cyclic quadrilateral from there. Okay, we can definitely derive a cyclic quadrilateral from there. Once again, a very standard proof. Let's not waste time doing the proof over here, because this is a very basic property known to you all, because you must have studied circles and so as cyclic quadrilaterals in your 9th standard, also 9th or 10th standard. I think circles is taught in 9th standard most likely. Chalo, next. Seventh one. Seventh one says the perpendicular from the center to the chord bisects the chord. Again, a very simple thing. Perpendicular from the center to the chord bisects the chord. Meaning of this thing? Perpendicular from a center. First of all, you draw the chord, and here we have the center. From the center, you are dropping a perpendicular. So this is saying that the perpendicular, this perpendicular from the center to the chord bisects the chord. Means this will bisect the chord. A very simple property. You can prove this easily. What you can do is you can draw a triangle and simply prove this thing. Okay. You can draw a triangle and simply prove this thing. A very simple thing. This is a very straightforward property which we are having. Just remember, the perpendicular from the center to the chord bisects the chord. Quickly take this down. And this is one of the important properties, I'm telling you. This is one of the most important properties you will face. Okay. If you have the radius given, let's say for instance, anything, any informations can be derived from here. Radius is given, okay. Radius is given, and a chord length is given, let's say. So we can definitely figure out this much length. Some sort of that thing you can definitely figure out, right? Or let's say perpendicular distance is given, radius is given. So we can figure out the chord length. Perpendicular distance is given, this much distance P is given, radius is given, okay, radius is given. So what we can do is we can figure out the chord length. Let's say for instance, if they are asking you to find out what is the chord length, what is the chord length, you can use the Pythagoras theorem, because this is 90 degree. You can use the Pythagoras theorem, you will get this thing, you will get this length. Let's say this length is D1 and let's say this length is D2. So you'll find what is D1 plus D2 from here directly. Okay, R and P is given, R and P is given. We can find D1 plus D2. That is the chord length. Okay. Chalo, next. Point number 8. Okay, now what is this point number 8 saying? Point number 8. Area of the segment of a circle. Area of the segment of a circle. Okay. A very, very important thing. Area of a segment of a circle. I'm telling you, there has been direct question both in ISI as well as CMI. Okay. And I ask you to remember the formula. Area of the segment of a circle. Just now I have said there are two types of segment. One is the minor segment and second one is the major segment. Okay. You are asked to find out this area. Let's say area of the segment of this circle. Let's say find out the area of the minor segment. What will be given? Radius is, let's say, given. And theta is given. Theta is what? Angle which is subtending at the center. And let's say R is given. Okay, radius. Both of them are radius. It's a triangle getting formed over here. And what is this? What is this? A secant or a chord, let's say. This much is chord, but the full line is a secant. Secant is actually, secant and chord are two different things. Chord is basically only this much. Chord is a part of the secant. Secant will pass through the circle. Secant will pass through the circle. Secant is a line which is passing through the circle. And chord is what? Chord is just a part of the secant. A secant is not a chord, but a chord is a secant, you can say. So chord is just a part of the secant. Anyways, so this much part you are asked to figure out which area, this shaded region. You have to find the area of the shaded region. Okay. So what I'm doing is, in trigonometry, you must have learned secant is line, chord is a line segment. Yes, yes, definitely. Secant is a line and chord is a line segment, you can say. So what I'm doing is, if we know this theta, we know this radius. So there is a formula for the area of the sector of a circle. Area of the sector. Do you know this formula for area of the sector of a circle, which is given by theta by 2 times of r square, or r square theta by 2? You must have seen this in coordinate geometry. No, sorry, not coordinate geometry. In trigonometry, most probably you must have seen. If you don't know this, please do write this down. The area of the sector of a circle is given by r square theta by 2. Very simple thing. Very simple thing. Why we are getting this formula? I'll tell you why we are getting this. And theta is in radian. Sector mane ye. Sector means this much. This is called a sector. This is called the sector of a circle. This is called the sector of a circle. Okay. So here kind of thing, this is a sector, you see. This total part is a sector. Getting my point? This total part is a sector of a circle. Let me remove this. So this is a sector of a circle. So here what you do, first of all, if you are not clear with this thing, if you are not clear with the formula, how we are getting this formula is a very straightforward thing. Is this r square theta by 2 is a very simple formula. What we are doing is, because we are taking in radian measures, right? We are taking in radian measures. We want the area of the sector of a circle, where this is theta. Okay. This is r and this is also r. This is theta and this is also r. So kind of theta is known to us. This is also a sector. For instance, if you take the entire circle, if you take the entire circle, then the area of the circle is what? Pi r square. Area of circle is what? Pi r square. We are taking the sector over just a portion of the circle. That is the sector of a circle. We are taking the portion. So here theta, we have some theta. So what I do is, this area of the sector is given by, if you take the full circle, we would have taken pi r square, but we are taking only a portion. So what we would have done is theta by 2 pi, theta by 2 pi, because we are taking in radian measures. So theta by 2 pi into the complete circle's area, which is pi r square. Getting my point? What I'm trying to say. If you would have taken the total angle, what is happening for this thing? You are taking 2 pi by 2 pi. That is why it is getting cancelled. 2 pi by 2 pi is getting cancelled and you're left out with pi r square. Theta is completely 2 pi over here. 360. Nahi samjhe? Not clear? Theta by 2 pi. Why we are doing theta by 2 pi? Is complete circle is what? 2 pi. And only a portion we are taking. So theta by 2 pi and multiplied by pi r square. This is the simplest proof I can show. So theta by 2 times of pi r square will give you this. Pi and pi cancels, or you're left out with r square theta by 2. That is why you're getting r square theta by 2. Okay, got the logic? Yes or no? Anyways, remember this formula for the time being. Area of the sector of a circle is given by r square theta upon 2. Now look at this thing. What is the use of this thing? What is the use of this? The use of this thing is area of the minor segment. We are going to find out the area of the minor segment. What I'm going to do is, for area of the minor segment, what I'm going to do is, I'll subtract the area of the triangle from this sector. I'll subtract the area of the sector, minus area of triangle. Area of sector means r square theta upon 2, right? And minus the area of the triangle. Area of the triangle is this. How will you find out? Half into half AB. If you have done solutions of triangle, half AB, half AB sine C. Remember, half multiplied by 2 sides, 2 consecutive sides, multiplied by the sine of angle in between them, angle enclosed by them. Half of r into r. Forgot. This is the theta. If this is ABC triangle, let's say, this is A, this is B, this is C. What is it? Half AB sine C, right? Half AB sine C, half AB and the angle in between them. Similarly, half AC sine B, angle enclosed between them. So half AB into sine theta. Yes or no? So this becomes r square theta by 2 minus of r square sine theta by 2. So can I take out r square common from here? So this becomes r square by 2 common. So we have left out with theta minus sine theta, where theta is the angle subtended at the center, which is the formula for the area of the minor segment. This is the area of the minor segment. Got it? Yes or no? Bolo. Got the logic? Okay. Fine then. One more question. You all have got this thing. You all have got this idea that how we have got this r square theta by 2. You all have got the proof of this. Yes or no? This proof is also clear. Area of the sector of a circle. Half sector's area is this. Half sector means this only. Half circle. The one which you are saying is half circle. Half circle is this much. This is half circle. The area of half circle is what? Area of the full circle divided by 2. Pi r square divided by 2. That's what we know. Area of the half circle is what? Pi r square divided by 2. है ना? How we are getting this pi r square? It is technically, how we are getting this pi r square is, the angle over here is 180 degrees, or pi actually. Angle over here is 180 degrees. You can say it's theta by 2 pi. So theta in this case is pi. Theta in this case is pi. This much is pi, na? Arey, this much is pi. This much is pi. This much is pi. Total angle is pi, na? This much is pi. This angle. It is pi units. Full circle is 360. Agar full circle, suppose for full circle, what happens? If you consider the full circle ke liye you are getting pi r square. So what is pi r square? It is technically this theta is 360 divided by 360 you are getting. Yes. 360 by 360. That is why it is getting cancelled and pi r square is left out. Then similarly, this is the full sector. Full sector means full circle. Half sector means half circle. Half sector means half circle. Okay. In that case, we are taking what? Angle is what? Theta. Theta by 2 pi into pi r square. So theta in this case is pi. Theta in this case is pi. This is pi. So we are taking pi by 2 pi into pi r square. That is why pi and pi cancels out. You are left out with 2 only. Area of the 1/4 of the sector. What is the 1/4 sector? 1/4 sector means this. 1/4. 1/4 sector. Okay. 1/4 sector. So what is the 1/4 sector? In this case, area, what is the angle? Angle created by this thing is what? 90 degrees. Angle created in between them is what? 90 degrees. So it's technically 90 by 2 pi. Getting my point? What I'm trying to say? It's technically 90 by 2 pi. 90 by 2 pi. Okay. Into pi r square. So that is why you are getting 90 by 2 pi. So 2 into 2 pi into pi r square. So pi and pi, once again, pi cancels out. So we have pi by 4 r square, which is the area of the 1/4 segment. 1/4 segment. So pi by 4 r, pi by 4 r square, or pi r square by 4. Got the logic now? What I'm trying to say? This is a very basic thing actually. Anyways, chalo aa jao. Acha, for instance, one question to you all. You have got the area of the minor segment. If I ask you to find out the area of the major segment, what will you do? Bolo. What will you do if I ask you to find out the area of the major segment? First. Area of the circle minus the area of the minor segment. Bas. Area of the total circle. So for area of major segment, you can write down, what will you do? Area of the total minus total circle, total area minus minor segment. Total circle माने pi r square minus r square divided by 2 theta minus sin theta. This is a very important formula. There has been direct formula based on this thing. Direct question based on this thing. So we ask students to remember this formula. Aaj next. Number 9. Number 9, you need not write down so much of statement. Simply draw 2 diagrams and simply write down the final statement. Bas, nothing else. Simply take down the diagram and write down the final statement. You need not write down so much things over there. What is given there? If 2 chords of a circle intersect either inside or outside, then the rectangle and so much of things. Simply see from here what they are trying to say. Simply see from here. 2 chords are there. Okay. 2 chords are there. Likewise, any 2 chords of a circle are there. Okay. Acha. And they are intersecting either inside or outside. So first case I'm taking, they are intersecting inside. They are intersecting inside the circle. 2 chords are there and they are intersecting inside the circle. Let's say one chord is given by name as AB and the second chord is given by name CD. And they are intersecting at O. They are intersecting at O. Okay. So what is the main formula? The formula is AO times of OB. AO times of OB is equal to CO times of OD. CO, this multiplied by this is equal to this multiplied by this. Any 2 chords are there. If the 2 chords are intersecting internally, the 2 chords are intersecting internally inside the circle. Okay. Then this is the main statement which you are supposed to write down. Okay, we have done this thing. Might be. And there is one more case. If you extend this thing to outside the circle, for instance, if the chords are intersecting externally, in what sense? You extend this thing. Simply take this O point outside. So O point is taken outside in this sense. The chords are intersecting externally. O point is over here now. O point is here. Okay. So here we have the names ABCD, let's say. ABCD. So similarly here also, see, OA times of OB. This statement is also valid for this. Same statement will work out for the second diagram also. The statement remains the same. This won't change. The statement remains the same. Okay. So what is this? OA times of OB. OA times of OB. For second one also. OA times of OB. AO or OA. OA times of OB equals to OC times of OD. OA times of OB. Full length into OB equals to OC times of OD. Statement will not change. Be it externally, be it internally, this will still remains the same. Okay. Also, do add one more point. If the 2 chords are intersecting externally, okay, then there is one more theorem, one more statement for it. Do add this as well. The tangents from O, the tangent means the point where this tangent will cut the or touch the circle actually at some point. The tangent, let me draw this first clearly. So this tangent, let's say this point is T. It's a tangent, not a chord. Tangent will touch the circle from outside at a point. Okay. Do add this thing with this statement itself. This same thing, OC times of OC, look at this, OC times of OD we have done. OC times of OD is the same as OA times of OB, which is the same as OT square, which is the same as OT square, which is the same as OT square. This is always true. A very important statement here. This is always true. Means if the chords are intersecting externally, if the chords are intersecting externally from the point of intersection of the chord, from the point of intersection which is lying outside the circle, point of intersection of what? Point of intersection of the two chords. From there, if you draw the tangent to any point on the circle, the tangent, this theorem will hold, means OC is equal to OC times of OD is also equal to OT square, means the length of the tangent whole square. OT means length of the tangent whole square. This theorem is always true, a very, very important theorem. Only write down, draw these two diagrams and take down the statement below. There are two cases. The first case in which we have taken the tangents, the chords which are lying inside the circle, and in the second case we have taken the chords are intersecting outside the circle. And also, if the chords are intersecting outside the circle, then from the point of intersection to any point on the circle you take a tangent. This is always equal to the length of the tangent whole square. Means OA times OB is equal to OC times OD, which is also equal to the length of the tangent whole square. Anywhere you take the tangent. Likewise, you know, from here, from this external point, you can take as many chords as possible, as many secants as possible, you can say. Okay, likewise, many such things, many chords can be generated likewise. From an external point, as many chords can be generated, but this theorem will always be true for any number of chords. Okay, no matter whatever chords, you just simply take any number of chords, and you can take infinitely many such chords which can be generated from an external point. Anyways, further we're going to see this thing, what is the application of this thing when we learn the tangent part. Tangents is a separate topic actually. Anyways, you should have the idea what you are going to face next. Slowly I'm going to give you the, you know, basic things over here, so that at least some things will be familiar to you when you learn the tangent part. Come down to the point number 9, point number 10. Point number 10, chalo, point number 10. Point number 10. The tangents at the extremities of a chord of a circle are equal. The tangents at the extremities of a chord are equal. The tangents at the extremities. What is the meaning of this thing? So first you take a chord. We have taken a chord. Tangents at the extremities of a chord. So extremities means the endpoints. So you take the endpoints. Then you take the tangents. Tangents at these points. The tangents of these points are intersecting at some point. Okay? The tangents from these 2 points are intersecting at some point. Let's say that point is P. The tangents here, not the chord. The chord is fine. The chord is there. Chords from the extremities, extreme points, we are having tangents, and the tangents are intersecting outside the circle. Okay? That's what we are having. They are saying the tangents at the extremities of the chord are equal in length. Means this tangent and this tangent will be equal in length. That's the simple theorem. Okay, so you have the chord AB. So PA and PB are always equal. Okay, PA and PB are always equal. This is the main thing. But there are certain deductions which can generate from here. A very important diagram which I'm going to show you next. It is very, very important actually. First, this is the theorem which we are having. Tangents at the extremities of the chord of a circle are equal. Okay. Now the thing is, over here, somewhere over here we have the center, let's say. Somewhere over here we have the center. Let's say the center is C, for an instance. There is one more thing to say from here. The proof is pretty simple. The proof is very simple. You join this thing, you join the center also, you join the center. Proof is very simple. You join the center also. You join the center with the point of intersection of the two tangents. You join the center with the point of intersection of the two tangents. Okay. Now look at this thing. This above these two triangles. Look at this. How I'm going to prove this thing. I am joining this center. I am joining this radius. Is the radius, right? And here also we have the radius. I am joining this thing. Now the thing is, the tangent and the radius will always create a subtending angle of 90 degrees. Obvious reasons. The tangent, one tangent, you take the radius. From here you take the tangent. This angle is always 90 degree. The radius and the tangent will always subtend an angle of 90 degrees. These two are always perpendicular. So the radius and the tangent will always subtend 90 degree. So as this will be also 90. These two are also 90 degree. Okay. Fine. Can I say that these two triangles are congruent triangles? Can I say these two triangles are congruent triangles from here? Can I say this? Which two triangles? These two upper triangles and this lower triangle. Can I say these two triangles are congruent triangles? Here we have right angle triangle over here, and these two sides are the same. Okay, RHS you can say. So these two triangles are congruent triangles. If these two triangles are congruent triangles, this angle and this angle will be the same. So as this angle and this angle will be the same. Are you getting my point? What I'm trying to say? We have proved that these two triangles are congruent triangles. So these two angles will be the same. So as these two angles. Got it? Got it? Yes or no? Okay. Achha, so what can I say? Can I say PC is the angle bisector of angle ACB? Can I say PC is the angle bisector of angle ACB, which is also the angle bisector of APB? Can I say this thing? PC is the angle bisector of these two angles. Yes or no? Have you got this? What I'm trying to say? PC is angle bisector of ACB and APB. Got this much? Yes or no? Fine. I'm trying to generate something. This is a very, very important diagram, I'm telling you. This diagram which I've given right now. That we have generated that these two angles are always the same. So if two tangents are there, which are tangents are meeting externally, they are intersecting externally, and the tangents are basically at the extremities of the chord, then it is very important to note that this angle joining the center, or the line joining the center, and the point of intersection of the two tangents will subtend the same type of angles over here. Means this angle and this angle will be the same. So as this angle and this angle, these two angles will be the same. Or kind of thing, you can say that CP is the angle bisector of this angle APB as well as angle ACB. Also, one more thing to see from here. Very carefully see. One more thing to see from here is these two angles are 90 degrees. So the sum of these two angles is what? 180. 90 plus 90 will give you 180. So can I say that ACBP is a cyclic quadrilateral? Or PACB is a concyclic? Can I say? Can I say PACB is concyclic? Also, PACB is concyclic. Means they are the vertices of cyclic quadrilateral. For what reason? This is 90 and this is also 90. 90 plus 90 is 180. Sum of the opposite angles is 180. Properties of cyclic quadrilateral. So definitely these two angles, sum of these two angles will be also 180. Angle C plus angle P will also be 180. So PACB is a cyclic quadrilateral. You know the circle will be somewhat like this. This will be the circle. The circle will go somewhat like this. Though it does not look like a circle. Got the logic? That's all. So PACB is a cyclic quadrilateral, or PACB is concyclic. That's all. That's all to say from here. Bolo, clear? Clear with the 10 theorems so far? Clear till here? Did you all get how we have proved this one? Especially this one is clear to you? This one, especially 10th one is very clear to you, that how we have proved the two triangles are congruent and the rest of the things. Chalo, one more last thing. I think one more theorem is left out. One more theorem is left out. Chalo, one more last theorem. Alternate segment theorem, 11th one. Alternate segment theorem. Alternate segment theorem. The angle between a tangent and a chord is equal to the angle in the alternate segment. What is the meaning of this thing? Chalo, simple diagram I'm drawing. Simple diagram. Two type of diagrams I'll draw to make you understand this thing. Angles in a same segment are equal. No, sorry. Angles in the alternate segment are equal. What I have done is I have taken a chord. I have taken a chord and I have taken a tangent, because in this theorem it is saying angle between tangent and a chord. So tangent is involved and chord is getting involved. So this angle, now it is saying that angle in the alternate segment. Forget about this thing. What is this? What is this saying? Simply see the diagram itself. This angle and this angle will be the same. This angle and this angle will be the same. Bas, that's all. Okay. Now, what is the meaning of this thing? Why they are saying segment, alternative segment, angle in the alternate segment? Because these two angles are different in different segments. You can see these two angles are in different segments. Okay. These two angles are in different segment. One is in this segment and one is in this segment. That's what they're trying to say. So angles in the alternate segments are also equal. That's what they're saying. Angle between a tangent. So I've taken a tangent and a chord. So this angle and this angle will be the same. So as this angle and this angle. That's all. That's all we have with the diagram. Let's not waste more time over here. Now let's now move on to the formal part of the formal part of your theory. I think we have some questions also. Yes, we do have some questions. Chalo, questions. There comes the question. This is a question from ISI entrance 2013. A question of geometry and a very basic question. And this question was asked in ISI 2013 UGB, means the subjective paper, not the objective one, 2013. Chalo, read the question, what they are trying to say. Let AD be a diameter of a circle of radius r units. So we have a circle which is having a diameter of circle which is having radius r units. B and C be the points on the semicircle with C distinct from A, so that AB is equal to BC is equal to R by 2. We have to find the ratio of the length of the chord CD to the radius. We have to find the ratio of the length of the chord CD to the radius. First, you need to draw the diagram. Okay. Always draw the diagrams in such cases. So we have a circle. We have a circle. Okay. And the circle is having the diameter to be AD. That's what they are given. The diameter of the circle is AD. Okay. We have taken the diameter to be AD. Now what they're saying is the radius of the circle is R units. Radius of the circle is R units. Okay. From this much is R units and this much is also R units. So diameter is 2R actually. BCB are points on the semicircle. BCB are points on a semicircle. So you consider one semicircle. let's say this semicircle I'm considering. Okay, this semicircle I'm considering B and C. You take B and C to be any points, any two different points I'm taking. Okay, that's what they have said. B and C are two different points on the semicircle with C distinct from A. Means A and C are not the same. Definitely, A and C are two distinct points. So that AB and BC is R by 2. So that AB and BC is also R by 2. Means this much. This is R by 2 and so as this is also R by 2. This is R by 2 and this is also R by 2. What we have to find? We have to find the length of the ratio of the length of the chord CD to the radius. Means we have to find CD also radius or rather CD by R we need to find out. Ratio of the length of the chord CD to the radius means they are asking you to find out what is CD upon R. This is your target. What is CD upon R? Fine. Now the thing is, if this is the radius, so as these are also radius. Let's see what we can generate from here. These two are also radius. This much we know. These two are also radius. Target, we have to target this thing, CD by R. We have to target CD. We have to target CD. Means this we have to target. This is our target to find CD. It's a chord, can you see? It's just a chord. CD is just a chord of the circle. So we have to target this chord. Okay. From the center to any point of the circumference, we are having radius. That is said to be radius. So we have generated these two radiuses actually. This is also R, so as this is also R. Let's see what else we can see. What else we can generate from here? What can we do? We know these two are R by 2 length given. This is R by 2, so as this is also R by 2. So can I say from here? So if this is theta, this is also theta. Obvious reasons, because if this is theta, so as this is also theta, because if this is R by 2, this is also R by 2. So angle in front of them will be the same, theta. So if both of them are theta, so what is the remaining part of the angle? How much is this much part? Pi minus 2 theta, because the total angle is what? Pi. So the remaining angle is what? Pi minus 2 theta. This much I can say. Okay. So what is the benefit? What we can do from here? Can we target CD? Can we target CD? Yes, very good. We have to use cosine rule. Now the question is why we use cosine rule. Angle enclosed between them is known to us. You have to find out CD now. So what is the best thing is what? You simply use the cosine rule. Because in cosine rule only, cosine rule, we have the formula where we directly approach the side along with the angles. Isn't it? The two angles, two sides are known to us. Two sides are known to us. Which two sides? These two sides. These two sides are known to us. Let me... These two sides are known to us. These two sides. This one and this one. So if two sides are known to us, so what is the main thing we do over here is we have the habit of using cosine rule. That's what we have seen in solutions of triangle. So cosine rule means what? Cos of angle what? Sorry, cos of. Let me make you remind what was cosine rule. What was cosine rule? If two triangles are given, in this sense, let's say triangle is ABC. This is A, B, and this we have C. Cosine rule means cos of, let's say, cos of angle A. Cos of angle A was what? First of all, we have A, so minus of A square. Opposite side, whichever is the opposite side, you will write down that first, minus of A square. Then the remaining sides are what? B square and C square. And then divided by 2 times of BC. Similarly, we have cos of angle B will be what? So B is there, so minus of opposite side B square. The remaining sides are what? A and C, it's A square C square divided by 2 times of AC. Okay, so if two sides are known to us, angle enclosed between them is known to us. So we can think of using cosine rule if we have to approach the third side, let's say. Okay, if we have to find out the third side, then we can think of this cosine rule. This is the basic thing. Okay, this is the basic thing what we can think of. So let us use, and I'm happy that one of you have at least said that this is the cosine rule. We have to use the cosine rule. So we can think of cosine rule here. So cos of what angle? Which angle? This angle. Pi minus 2 theta. Pi minus 2 theta. Cos of this angle, which is pi minus 2 theta. Okay, now the thing is, Now the thing is, which one is the opposite side? Opposite side is CD. Opposite side of what? Angle pi minus 2 theta. Opposite side of angle pi minus 2 theta, which is CD. So minus of CD square. The remaining sides are what? Remaining sides are R and R. So R square plus R square divided by 2 times of R. 2 times of R into R. Right? Getting my point? You give the name for the center, let's say. OC square plus OD square minus of CD square divided by 2 times of OC times of OD. So 2R into R. Got it? Got it? Yes or no? So we are getting 2R square minus of CD square divided by 2R square. Okay, cos pi minus 2 theta is minus of cos 2 theta. So minus of cos 2 theta. So you can see how simply we are using, in a geometry question, we are also using solutions of triangle, concepts of trigonometry. So minus of cos 2 theta. So actually, can you see from here that we have a, if we just figure out what is this cos 2 theta, so we can actually figure out this CD by R, because this ratio, can you figure out that this ratio we can figure out CD square by R square. We are getting some ratio of CD by R, which is our original target CD by R. So minus of cos 2 theta is basically 2R square by R square is 1. Make it as 1 minus of CD square by 2R square. Or let's just multiply with the minus and remove this minus from the cos 2 theta part. Okay, so we are left out with 1 minus, or rather CD square upon 2R square, CD square upon 2R square minus 1 is equal to cos of 2 theta. So we are technically finding CD square by 2R square, which is 1 plus cos 2 theta. Now the question is, how do we know what is cos 2 theta? Theta is not known to us. Target is to find theta next, because we need to simplify the ratio. Find cos theta by cosine rule. He is saying correctly. Auditro is saying ki find cos theta by cosine rule once again. Use cos theta in any of this triangle. You use cos theta because R is known to us. R is known to us. ठीक है? So what you do? You find cos theta from cosine rule. ठीक है? अच्छा. Find cos theta, because why we find cos theta? That is also one question, because 1 plus cos 2 theta, or rather cos 2 theta is 2 cos square theta minus 1. So this is 2 cos square theta minus 1. So 1 plus 2 cos square theta minus 1. So 1 and minus 1 will cancel out. You are left out with 2 cos square theta. And further we can find cos theta from the second triangle. One more triangle. In what sense? Cos theta. Let's find what is cos theta. Cos theta means R square plus R square. You take for any triangle. Let's say I take this triangle. So R square plus R square minus of R square by 2. R by 2 whole square, sorry. Divided by 2 into R into R. Because angle enclosed between them is what? Theta. So minus of R by 2 whole square. Opposite side is what? R by 2. And the remaining sides are what? R and R. So R square plus R square divided by 2R into R. 2R into R means R square only. I directly write this to be 2R square. Okay. So we find what is R from here, or rather cos theta from here, and then we'll simply put the value. Okay. Chalo, what is this? R square means 2R square. This is 2R square plus R square by 4 upon 2R square. So how much is this? 2R square plus R square by 4. So further what we can see from here is R square and R square is getting cancelled. So we are left out with what? 2 by 4. 2 by 4 na. 4 by 8. 8 minus. This is 2R square. So 8 plus 1. 9 by 4 divided by 9 na. This was plus though. This was plus na, minus. So 8 minus 1. 7 by 4. 7 by 4 divided by 2. So 7 by 8 is remaining. 7 by 8. So we have got the value of what? 7 by 8. What? Cos theta. Cos theta is 7 by 8. So 2 cos square theta. So what is this? So 2 cos square theta is nothing but 2 times of 7 by 8 whole square. 7 by 8 whole square. That's what we are having. And what is this? What is this actually? What is this? CD square by 2R square. CD square by 2R square is 2 times of 7 by 8 whole square, or more specifically CD upon R square. CD upon R whole square is equal to 4 into 7 by 8 whole square. Just simply take the square root on both the sides, and here the ratio will be positive because is the ratio of the two sides, so we'll take the positive version only. Okay, so we'll take the positive square root only. So finally, what is the answer? You take the square root directly, so we'll get CD by R. Take the square root. So answer is what? 2 times of 7 by 8. So we have 7 by 4. 7 by 4 is the answer. CD by R is what? 7 by 8. Got the question? A nice question, and question from ISI entrance. So CD by R is 7:4. And this is not even a question from your all the theorems which you have learned. It's a question from solutions of triangle rather. We have used cosine rule only, nothing else. It's a question from solutions of triangle. Chalo, next. One more question. And this is from ISI 2017. If you have the tomato book, then you need not take this down, or just simply take a screenshot of this thing. You can take this down afterwards. Chalo, look at the question. Consider a circle of radius 6 as given in the diagram below. So we have a circle of radius 6. Okay. Let BCDE, okay, be points on the circle such that BD and CE, when extended, intersects at A. Okay, so BD is being extended, so as CE, BD and CE are extended and they are intersecting at A. Fine. AD and AE have length 5 and 4 respectively. So AD is 5. AD is 5. Do draw the diagram. AD is 5 and AE is 4 units. Show that the length of BC is this. Show that the length of BC means we have to target this BC, the base of the triangle, right angle triangle, which you all can see from here. Let us see in what sense we can approach. Circle of radius 6 is given. So radius is 6 units. So kind of thing, if you take the radius, center is somewhere over here. We have the center. Okay, you take the center over here somewhere. This is center C, let's say. Don't give C, we do have C, so give this some different name. Let's say this is O. Okay. Fine. So the thing is, how do we approach this first? One by one. Target is BC. Target is BC. One thing I can see from here. One thing I can see from here is, if you join this, let's see what we can get from here. If you join this, this CD is the diameter, and CD is diameter, and CD is 12 units. CD is 12 units. Why 12? Because radius is given to be 6 units. CD is 12 units. Okay. So let me write down also one by one. CD is 12 units. Acha. What else we can generate from here? Acha, do one thing. Can you see from here? Can you see from here that if I join this, if I join this one, if I join DE, a bit of construction which we have to do from here just by basic visualization. Like I can see one thing from here. If you join DE, so this BCDE or rather DBCE is a cyclic quadrilateral. Yes or no? BCDE, the 4 points are concyclic. So I can say that they are cyclic quadrilateral, right? And here we have a 90 degree. So if this is 90, so the remaining part is also 90 degree. Means this is also 90 degree. Okay. So here what I'm doing is join what? Join DE. So after joining DE, what we are getting is BCDE or DBCE. DBCE is a cyclic quadrilateral. It's concyclic. This is concyclic. This much we can generate. But what is the benefit? One more thing we can find out this length also. Let's see one by one. One more thing. If this is 90, the remaining part is also 90. So the upper triangle is a right angle triangle. So if the upper triangle is a right angle triangle, so how much is the base? This is perpendicular is 4, hypotenuse is 5. So what is the base? 3. Yes or no? So in the upper triangle means which triangle? I am talking about AD. In triangle AD, in triangle AD, by Pythagoras theorem, what we are having is AE square plus DE square is AD square. So which means 4 square plus DE square is equal to 5 square. माने DE square is equal to 9. है ना? 25 minus 16. So what is D? DE is 3. We are finding DE. DE is 3 units. And this much is 3 units. So what can we do from here? Acha, DE is 3 units. Further, can we find out this triangle? Further, can we find out this CE length from here using the same thing, Pythagoras theorem once again? Because this is 12, right? This is 12. And this is 3. So we can find out this length now. We can find out this length. CE. Yes or no? Again, Pythagoras theorem. So by Pythagoras theorem, what we can say from here is, again in triangle, which triangle is this? This is triangle DEC. In triangle DEC. Again in triangle DEC, can I use the same, similarly, Pythagoras theorem, hypotenuse square. This is the hypotenuse. We have the perpendicular, right? Perpendicular, let's say perpendicular is what? 3. So 3 square plus, let's say this length is x. So x square I am writing. So what is this? 144. And here we have 9 plus x square. So x square is what? 135. X square is 135. X square is 135. So what is x? This won't be a perfect square kind of thing. So we have root over of 135. What is root over of 135? Simplified form. 135, I think this will go with 5. 5 times 15. I think 3 root 15. Am I correct? Am I correct? 3 root 15. 135 now. 135 times of 5, 15 to 15. 3 root 15. Am I correct? Okay, fine. Okay. So we have got this much. But what is the logic? I mean, something we have got this length to be 3 root 15. That is fine. But what is the benefit? We have found out this much length, 3 root 15. Okay. So, can we think of some other technique by which we can obtain? My target is to find out. If I find out, they have asked you to find out BC, right? They have asked you to find out BC. If I find out what is AB, length of AB and length of AC, so we can definitely find the base. It's a right angle triangle. Absolutely. CA times of CE. So we use that theorem. Which one? The two secants or the two chords are intersecting outside the circle. Here the two chords are what? DB, BD and EC. BD and EC are kind of intersecting outside the circle. Okay. BD and EC are intersecting outside the circle. So we can think of that. We can think of the this method. Means what to say is this thing, CA times of CE. Okay. CA times of CE is equal to AB times of AD by that theorem. Yes. So the rest you all can do from here. So CA times of, let's do the calculation. Let's finish up this question. So we have CA times of CA is how much? CA is CA. Where is CA? CA is this. CA is 4 plus 3 root 15. So 4 plus 3 root 15 times of CE. CE mane 3 times of root 15 equals to AB times of AD. AB mane AB is this. AB is not known to us. Okay. Or rather we can say AB is what? You consider this to be. You consider this to be Y. Consider this to be Y, let's say. So AB is what? 5 plus Y. Fine. AB is 5 plus Y times of AD, which is 5. So the right hand side becomes more simplified to 25 plus 5Y. Right. 25 plus 5Y. Got the logic? We have used that theorem. By the theorem, you can give the name of the theorem. So what we get from here, let's simplify from here. So we have from here is wait, 1 second. So let's simplify. We can find Y from here directly. What is Y from here? So 3 times of, how much is this? Root 4, 12, root 15. 12 root 15. Am I correct? I am doing this correctly? There is some mistake, I guess. There is a mistake. There is a mistake. Most of you haven't seen this thing. What is the mistake? This is AC times of AE. AC times of AE, not CE. AC times of AE, right? That's the theorem. AC times of AE. This was the theorem. AC times of, where is it? This one. OA times of OB, the outside part. OA times of OB. OB was what? Outside part. So it's technically not CA times of CE. CA times of CE. Okay. Pradyun, please correct this thing. CA times of not CE. It's CA times of AE. So it's CA times of AE. Outside part. So it's CA times of 4. So this becomes 16 plus 12 root 15 is basically 25 plus 5y. 25 plus 5y. Simply solve for 5 plus y from here. So 5 plus y is how much? 5 plus y is this is 16 plus 12 root 15 and divided by 5. So it's kind of a 16 plus 12 root 15 divided by 5 whole square plus BC square. Got it? Now we have to do a bit of manipulation from here. We have to do a bit of manipulation. Means simplification from here. Simplify and tell me what you're getting from here. Simplify and tell me what you're getting from here. How do we simplify this thing? We'll break this into square. No, definitely not. We can think of taking something common from here. At least something to you're getting common from here. 4 plus 3y. Just solve from here. 4 plus 3y. 4 plus how much is this? 4 plus 3 root 15. Okay. And I do a bit of simplification from here. So we have, you take out how much? You take out 4 common from here. We are getting 4 common, right? You take out 4 common from here. So we have 4 plus 4 square, or rather you are taking 4 square common. So 16. Okay. So this becomes what? 4 plus 3 root 15 divided by 5 whole square and plus BC square. There was a triangle below also, so you would have simply worked out with y also. That is also much more simpler. Chalo, same thing, you'll get the same answer. Now you can clearly see, I can take out 4 plus 3 root 15 common. 4 plus 3 root 15 whole square common. 4 plus 3 root 15 whole square I am taking out common. So this becomes, finally, this becomes common. So 1 minus 16 by 5. 25. 16 by 25 is left out, which is BC square. And simply take the square root. So we are done. You simply take the square root next. Simply take the square root. I'm doing it over here. So BC, you take the square root. So this will become 4 plus 3 root 15 And here we are left out with what? 1 minus 25 minus 16, which is times of 25 minus 16, which is 9 by 25, which is 3 by 5, 3 by 5, and we are done. That's all. So just simply multiply next. So this is 12 plus 9 root 15, and that's what they have asked to prove. 12 plus 9 root 15. Entire thing is calculation based. 12 plus 9 root 15 divided by 5. Chalo. Nice question, right? Very nice question. Next, we come down to the actual definition of circles. Now we start with the actual 11th part of circles. Till now, we were just discussing the class 10th portion, and we have discussed advanced question from that section. Now we move on to the 11th part of circles. So first, there comes the very basic definition, which is known to you all. Let me just show you the different PDF which I'm having. This PDF is there in your portal, actually. It's a part of my book which I'm writing. Okay. Okay, come down to this one. Circles. What is a circle? A definition is known to all of you. The definition of circle. What is the basic definition of circle saying? Ki circle is the locus of a point which moves in a plane so that the distance from a fixed point is always constant. This is known to you. So we have a fixed point. We have a fixed point. Let's say a fixed point is there. From a fixed point, you are moving a certain distance. From a fixed point, you are moving at a certain distance. Let's say that distance is r. You are moving r distance. This fixed point is given by, let's say, anything. You can take AB. Okay. And on a plane, you are taking a fixed point. You are moving at a certain distance such that this distance is constant. Now, this distance can be taken on anywhere. This distance can be taken here. This distance can be taken here. This distance can be taken here. But the distance remains constant. This can be taken here and so on. The distance is taken in such a way that it is constant, fixed, and it is taken from a fixed point, which is AB, such that this generates the locus generated by this system will be said to be a circle. When you join all of these lines, the figures generated will be said to be a circle. And that is what we have studied in straight line also. You remember that when we have discussed locus, I have said this thing previously. Whenever we are taking a fixed distance from a fixed point, we are taking a certain distance and we are moving around the plane, keeping the distance to be constant. Okay. And that is known as what? That locus formed. Locus is what? Just a path. And the locus will be a curve. The curve traced out will be a circle. And that is what they are saying. The circle is the locus of a point which moves in a plane so that its distance from a fixed point is always constant. Distance from a fixed point is always constant. Now, this fixed point, what is this fixed point known as? This fixed point is this only. This is the fixed point. This fixed point is, this is the fixed point. This is the fixed point. Oops, sorry. This is the fixed point. This is the fixed point. The fixed point is called the center of the circle, and the fixed distance is what? The radius. Okay, the fixed distance, all these distances are called the radius. Okay, the distances are called the radius. That's all. That's we have the definition. So a fixed point is called the center and the fixed distance is called the radius of the circle. Fine. So next I come down to the equation of the circle. Next we come down to the equation of the circle. Standard equation of the circle. Again I come down to this. Write down standard equation of the circle. Give the heading standard equation of a circle. Or standard form, actually. The standard form of a circle says the circle, how we are getting this standard form, you see from here, we have the fixed point. This fixed point was AB. Okay, and along this, we are taking a fixed distance, keeping a constant distance. We are taking let's say, for instance, you are traveling r units further from this point, and you arrive to some point. That point is given by x comma y, variable point. X comma y is variable point. That's what you used to get in locus, right? In locus, you used to get a variable point. So this is the variable point which will travel on the boundary of the circle. So this is xy. So you simply, that by the definition of this thing, it is saying that if you find out the distance between these two, the distance between these 2 points will give you the radius by definition. the distance between these two. So what is the distance? Distance is calculated by x minus a whole square plus y minus b whole square. Okay. And this will be equal to r, but the distance is given by root over of this thing. So once you square both the sides, you will get r square also. So we don't take square root, so we'll take this to be r square. And this is the basic standard form of the circle, where a and b is the center and r is the radius of the circle. Very simple thing. A and B is the center and R is the radius of the circle. Fine. Next. Next, we move on to general form of the circle. Now, this is the main form. This is the main form which you need to take care of. Let's derive from here itself. Means from this section only we can derive. What I'll do, I'll simply expand this thing. You expand this thing and you'll see from here x square plus a square minus of 2ab, so minus of 2x plus y square plus b square minus of 2by is equal to r square. Right? So what is left out from here? X square plus y square. X square plus y square is there. X square plus y square, and then what is left out? Minus of 2ax minus of 2by, and then the remaining constant part. What is the constant part remaining? A square plus b square minus of r square. The constant part which is left out. What is the logic? Okay. And this, after adjustment, after adjusting the constants and all, this has been given in this format: x square plus y square. Now we have to compare x square plus y square plus 2gx plus 2fy plus c. I'm removing this part. Now you compare from here. So x square plus y square plus 2gx plus 2fy plus c. This entire thing was taken to be constant. The constant is the constant. Okay. Acha. Minus of 2gx, x square plus y square plus 2gx plus 2fy. So what I do, I compare with this thing. So once you compare, you'll get the things from here. Once you compare with this equation, x square plus y square plus 2gx plus 2fy plus c. Compare with the equation which is given in the next page. Okay. You'll get the value of g, you'll get the value of f also from here, and you'll get the value of c also. Okay, the entire constant. This is being simplified. We don't see the we don't have the habit of remembering this complicated one. So we have given a simplified form. This is the simplified form. X square plus y square plus 2gx plus 2fy plus c is equal to 0. And here you can definitely see from here how we are giving this thing. Center is this and radius is this. That also we are going to see. But look at this thing first. You can clearly see from here. If you just compare also, you can definitely see from here. What is the center? Means the radius. Radius is what? A plus b square. C is what? C is basically a square plus b square minus of r square. C is what? C is a square plus b square minus of r square. Okay. But the thing is, over here, you need to give the center in terms of g and f. You have to give the center in terms of g and f. So from here, we can find what is a and b in terms of g, and simply put the value of a and b in terms of g, you will get what is c. Okay. But you need to compare. Compare with what? Compare with the general equation of second degree. We have to compare with the general equation of second degree. So give the heading next, general equation of circle. This is the general form, and the center is given by this. Center is given by this, and radius is given by this. Very simple to derive also. Very simple to derive, or you can derive. One more thing I need to show is, one more thing to show from here is, you can derive from here also. You know in what sense? X square plus 2gx is there, right? 2gx, so 2ab plus b square. Just to bring this into perfect square, what is missing? G is missing, g square is missing. So I'm taking one g square, so subtract minus of g square also. You can derive from here also. Means we can, from here, we can bring into the standard form. From the standard form, we can bring into the general form, and from the general form also we can bring into standard form. So x square plus 2gx plus g square, right? Okay, next is what? This part will become a perfect square. Similarly, let me move the constant a bit. So this is minus of g square. Keep it as minus of g square. Similarly, from here, y square, combining this thing, 2fy plus, what is left out? We need what? We need plus y, sorry, plus f square. So f square was not there, so minus of f square. We are taking extra, and plus c was there. So now can you see from here? So this one becomes what? X plus g whole square plus y plus f whole square is basically g square plus f square minus of c. Getting my point? Now can you relate with this thing? So in the place of writing this to be g square plus f square minus c, I'll write this to be g square plus f square root over of g square plus f square minus c whole square. Now can you compare with this thing? Compare with which form? X minus, I'm writing this purposely, I'm writing this to be x minus minus g whole square plus y minus minus f. X minus x1, or rather x minus a whole square. So what is the center? Can you compare? The center is what now? Minus of g comma minus f. And radius is what? Radius is root over of g square plus f square minus c. Got the logic? So vice versa also you can do. Vice versa also you can do. Means from general form you can bring into the standard form. Yes or no? And from the standard form, if you are bringing from the standard form to general form, you need to convert. Okay, you need to convert and then compare. Anyways, you need not remember so much of things. What you need to remember: standard form, then the general form, and then the radius formula and center formula. Radius formula and center formula. Okay. Now the thing is over here, the main thing is you need to, for general equation of the circle, to give the center to be minus g and minus f if the coefficients of x square is something different. Okay. If the coefficient of x square is different, please make this as 1 and then solve. Please make this as 1 and then solve. Means you divide by a and then solve. Now you will ask the question that compare with this. Next, no more questions. You compare with the general equation of second degree. By general equation of second degree. By general equation of second degree, what do we know? Ax square plus by square plus 2hxy, right? Plus 2gx plus 2fy plus c is equal to 0. This is the general equation of second degree. Last class we have studied. So what is h? Or rather this term, can you see over here in the general equation of the circle, xy term is absent. Means h is 0. What else? Coefficient of a, coefficient of x square is the same as coefficient of y square. And h is equal to 0. Okay. The sufficient condition is coefficient of x square is equal to coefficient of y square. The necessary condition is to find out the center. You should always, let's say if the coefficient is some different number, first of all, here we are having 1, right? If the coefficient are of some different number, in what sense? Let's say the coefficients are some different number, 2x square plus 2y square plus 2gx plus 2fy plus c is equal to 0. You are supposed to make this as free, make this as 1. Make this as 1 and then solve. Means you divide by 2, so this becomes gx plus fy plus c is equal to 0. And then you find out the center. So if this is not 1, this is the sufficient condition that coefficient of x square is equal to coefficient of y square. The necessary condition is you are supposed to make this as 1 and then find for the solve for the center and solve for the radius. Then you find what is g and f. So what is g and f from here? G and f will be x square. Now compare x square plus y square plus 2gx. Right? So 2 into g by 2. 2 into g by 2x into 2 times of f by 2. Why we do this thing? Because center is given by what? Center is given by minus of g by 2 comma minus of f by 2. Center is given by the coefficient of x. But coefficient of x means 2g. That g is the center, minus g comma minus f. Okay. I'm getting my point, what I'm trying to say from here. Yes or no? This is the equation of the second degree curve. So the speciality of circle, to this be a circle, the general equation of the conic, which we have seen in the last class to be a circle, coefficient of x square must be equal to the coefficient of y square, and age must be equal to 0. The condition for circle. Okay, age must be equal to 0. Got my point? I think that's what I've given in my notes down also. Below. All these things I have said. The general equation of the circle which you need to remember is x square plus y square plus 2gx plus 2fy plus c is 0, whose center is at minus f comma minus g comma minus f. Okay, minus g comma minus x. If this is not free, if this is not the same, if this is not 1, you are supposed to make this as 1 and then solve. If these two are different, then definitely it's not a circle, because the main condition, the necessary condition is coefficient of x square must be equal to coefficient of y square. They may be different. If different, we have to divide and then solve. If different, we have to divide and then solve. Otherwise, if they are different, let's say 2 and 3 are given, that cannot be a circle. Maybe something else, but that cannot be a circle. Okay, so center is at minus g comma minus f, and radius is root over of g square plus f square minus c. Just now we have seen. Okay, where is that comparison gone? Just a second, let me see. I think the comparison is, look at this. We observe that the general equation of the circle has the following characteristics. It is an equation of second degree in x and y. We have seen where there are no product terms of xy. There are no product terms of xy. The xy product term is absent. Xy product term is absent. So there is no product term xy. And coefficient of x square, just now we have seen, coefficient of x square is equal to coefficient of y square is equal to 1. They may be different, not equal to 1. They may be not different, means x square and y square. This must be true definitely. This is absolutely a necessary condition. This is absolutely a necessary condition, necessary and sufficient condition. Let's say if you're getting 1 also, then there is not at all, there is no problem at all. But if it is not 1, you're supposed to make that as 1. It's easy to make that 1, right? You can just simply make that 1 and then solve. So we have given a general formula. So kind of this thing you can see. What is the third one saying? Half times of coefficient of x square plus half times of coefficient of y square minus a constant term is a positive real number. You see from there, half times of coefficient of x square is what? What is the half times of coefficient of x? Means coefficient of x is what? Minus, whatever is the coefficient of x? 2g. So what is it? G square plus f square minus c is a positive real number, obviously. Otherwise, how will you define the radius? G square plus f square minus c. What is this? Half times of coefficient of x square means g square. G square plus f square minus c is a positive real number. This is a positive real number, r plus. Because this can be 0 also. But if this becomes 0, square root of 0 is 0, the radius will become 0. And if the radius becomes 0, it's a point circle. It's just a point. Just a point like this. Point circle. If radius becomes 0, it's a point circle. Take down these three conditions. And if the square root quantity is less than 0, then this will be a complex number. In that case, you will have an imaginary number. You cannot get a real circle in that case. So it's kind of, you can say that it's an imaginary circle. So definitely this must be a positive real number. Radius, this simply means the radius. This must be a positive real number because half times of coefficient of x square, the radius is given by half times coefficient of x whole square plus half times coefficient of y whole square minus of the constant term, minus c. That's what they have said. I hope you have taken this down. Right? Done. Chalo, next. Acha, there are few points over here I was seeing. Do take this point also. Yeah, this one. Take down in short. If g square plus f square minus c is greater than 0, if g square plus f square minus c is greater than 0, then the radius of the circle is real and also the circle is real. Okay, if g square plus f square minus c is greater than 0, simply write down if g square minus c square is greater than 0, then circle is real circle. If this is greater than 0, then circle is real. In short, then circle is real. If g square plus f square minus c is equal to 0, then the radius of the circle is what? 0. radius will be 0. In that case, the circle is known as a point circle. Just a point. In that case, the circle is known as a point circle. And lastly, if g square plus f square minus c is less than 0, then the radius of the circle is also imaginary. Okay, but the center is real. Yeah, center we can find, definitely. Center is real. But anyways, you cannot draw the circle in the real plane, but it's a kind of a, what can you say, imaginary circle. Steps have been given over here. You may just see with the help of the question itself what we are going to do. You need not write this thing, you have this. We are going to see this with the help of the question. Just quickly, I'll explain the steps. Rule to write down the center and radius of a circle. Very simple rules are there. Make sure that the coefficient of x square and coefficient of y square is 1. Okay. Make sure that this has to be 1. If not 1, then divide throughout and make it to be 1. Make it to be 1 and then solve. Then what you do is you compare this equation with what? X square plus y square plus 2gx plus 2fy plus c is equal to 0. Remember, I have said x square plus y square plus 2gx plus 2fy plus c is 0. Then from there you compare what is g and what is f. What is g? Half times the coefficient of x. Remember, half times coefficient of x, half times coefficient of y. And c is the constant term. Fine. And then finally, what we do? We use that to find out the equation of the circle and the radius of the circle also. We check that whether g square plus f square, we simply check that whether g square plus f square minus c is greater than 0 or not. Then the center, 0 or more than 0. It may be 0 also. If 0, then it's a point circle. If more than 0, then we have a real circle, a complete big circle which you are seeing. So far, so we haven't seen any kind of point circle. All circles we have dealt with and you will be dealing with will be a real circle only. So check that g square plus f square minus c is greater than 0 or not. And from there we can find out the center. Minus g minus f and radius is root over of g square plus f square minus c. Now write down one definition with what is known as concentric circle. Write down the definition of concentric circle. Circles having same center and different radii are called concentric circles. Circles having same center and different radii are called concentric circles. Write down this definition of concentric circles. Circles having same center and different radii are called concentric circles. And lastly, we have equal circles. Write down what is equal circles. Circles having equal radius are called equal circles. Circles having equal radius is called equal circles. Okay. Circles having equal radius are called equal circles. One small question. Find the equation of the circle. Very small question. Find the equation of the circle whose radius is 10 units and center is minus 5, minus 6. All of you can do it. What is it? Minus of 5 minus minus 5. So x plus 5 whole square plus y plus 6 whole square is equal to radius r square. Now you simplify this thing, whatever is the answer. You further want to simplify this thing, x square plus 25x. Sorry, 25. X square plus 25 plus 10x. Here we are having y square plus 36 plus 12y is equal to 100. You simplify this thing, whatever is the answer. Chalo, next. Equation of the circle. Do this one. Equation of the circle of radius 13 units and whose center lies on the x-axis and passes through 4, 5. So what is this? We have a circle whose radius is 13 units and center lies on the x-axis. So draw the diagram very carefully. I want you all to draw the diagram first and try out with this question. Very simple question. It's a circle which is having the center at the center lies on the x-axis and passes through 4, 5. So the center is where? Center is at the center lies on the x-axis. So center will lie over here on the x-axis. X-axis means the center is of the form a, 0. Definitely. Radius is 13 units. So radius is 13 units. 13 units is the radius. And it is passing through a point 4, 5. 4, 5 is there in the first quadrant only. So I'm taking here itself 4, 5. So it's kind of a circle like this. This must be the diagram. Okay, this must be the diagram. This is the circle looking like. So we have how much? So what we can do from here? What they have asked to find out? They have asked to find out the equation of such a circle. So what we can do? So we just simply find out using the definition. So 4 minus a distance, we can find the distance formula. 4 minus a whole square plus 5 whole square, 5 square, 5 minus 0. So 5 square is equal to 13 square. So 4 minus a whole square. 4 minus a whole square is what? 13 square is 13 square minus 5 square, which is 12 square. 144. 13 square is 169 minus of 25 is 144, 12 square. So 4 minus a is what? 4 minus a is plus minus 12. So once you will be getting 4 minus a is plus 12, and second you will be getting 4 minus a is minus 12. You're supposed to get two values of a. A is what? A is 16 from here, right? Sorry, a is minus 8. A is minus 8 from here, right? 4 minus 12. 4 minus 12. So a is minus 8. And what is a from here? A is 16 from here. So there are two values of a. So corresponding to two values of a, you are supposed to get two circles because there are two centers. Definitely there are two centers. One negative center is also possible. You have taken the center over here in the first quadrant. What if this would have been in the negative quadrant, means on the negative side of the x-axis? The center could have been over here also. That is why you are getting one of the center is what? 16, 0, and the second center is minus of 8, 0. That's why you're getting two centers. We have got the center, so we can definitely find out the radius is known to us. So you are supposed to get the two equations of the circle. So first one is what? For this center minus 8, 0, we are having x minus 8, sorry, x plus 8 whole square plus y minus 0 means y square is equal to r square. What is r? 13 square. And for this one, we are having x plus 8 whole square. Sorry, x minus 16 whole square. X minus 16 whole square plus y square is equal to r square, 13 square. These are the two equations. Okay. These are the for two true values of a, we are getting two circles. Homework question, write down. Screenshot. Okay. That's all for the day.